Yo, what's popping, y'all? So, man, I seen this video, man. I just because there's a couple things going viral on X right now, and one of them is this DeepSeek situation. If you don't know about DeepSeek, just a quick overview. DeepSeek is a company from China that basically they released a competitor to ChatGPT, and it caught the whole industry, the whole world, the whole earth by storm. And every day just new things keep popping up. So I saw this video. I'm like, let me check this out, man. This is a very, I'm very, very. I went and I've been using and testing it out and just checking different things. I'm still trying to find different ways that these things can help me in a more practical standpoint to make money. Because that's the whole. If you're not trying to make bread off this, what are you trying? You know what I'm saying? What's the point? You feel me? It can help you obviously navigate through life with certain things. You know what I'm saying? But like at the end of the day, most of us are trying to make some bread off this shit. You feel me? So I just seen this. I was like, let me take a listen to what Wes Roth. Shout out to Wes Roth. How you doing, bro? Let's react to Wes Roth and see see what he's talking about with this. I'm gonna hit thumbs up on this video. If you enjoy my reaction and my commentary, you know what I'm saying, do the same for me, but
Now, a few days ago, this was posted on Twitter, where it appeared that two R1s, while talking to each other, developed their own alien language, their own cipher, to be able to communicate to each other without anybody else knowing what they were talking about. Here's kind of what
what?
that language looked
You want ice cream? Okay, let me go. Let's go get. All right, let's check this out.
like. Here's the thing: later, we find out this was already existing sort of language that's available online. So very likely they just pulled it off the internet, where it's called alien language, and kind of here are the symbols used with a decryption. But there are tons of examples where, for example, R1 slips into Chinese in its chain of thought to think through something in Chinese before finally replying in English. I've actually seen where O3 Mini High randomly shifts into Spanish while thinking about how to build a reinforcement learning training pipeline for a Tetris playing AI. As you can see here, it's going in English, switches over to Spanish,
I
and
can't
speaks in Spanish.
remember.
The final answers in English, but kind of neat. Now, of course, so far this makes sense. This is nothing new. I mean, if you speak multiple languages, they might be easier, more efficient ways of thinking thhrou something or saying something in a different language. You might slip into that language to kind of process that side of your thoughts and then come back to it.
And there's a country
But here's the thing: we
song
do have examples of these
for
LMs creating their
Oh
own
my
language, not
God.
just a cipher, where it's still,
All right, sorry, y'all. I had a yeah, my fault. I don't cut my videos, so sorry about that random hiccup there. Let's go ahead and
here's
get
the
back
thing:
to
later
this.
we find out this was already existing. Now, a few days ago, this was posted on Twitter, where it appeared that two R1s, while talking to each other, developed their own alien language, their own cipher, to be able to communicate to
That is absolutely crazy. What?
each other without anybody else knowing what they were talking about. Here's kind of what that language looked like. Here's the thing: later we find out this was already existing sort of language that's available online. So very likely they just pulled it off the internet, where it's called alien
Whoa.
language, and kind of here are the symbols used with a decryption. But there are tons of examples where, for example,
Wow.
R1 slips into Chinese in its chain of thought to think through something in Chinese before finally replying in English. I've actually seen where O3 Mini High randomly shifts into Spanish while thinking about how to build a reinforcement learning training pipeline for a Tetris
Interesting.
playing AI. As you can see here, it's going in English, switches over to Spanish, and just continues in Spanish. The final answers in English, but kind of neat. Now, of course, so far this
That's
makes sense. This is nothing
interesting.
new. I mean, if you speak multiple languages, they might be easier, more efficient ways of thinking through something or saying something in a different language. You slip into that
Hmm.
language to kind of process that side of your thoughts and then come back to a different language, whatever. But here's the thing: we do have examples.
Almost like, you know what I'm saying, with music. Sometimes it's like, you know, so for example, in Nigeria, you have the tracks that are like, Yoruba. Sometimes there's certain things you can say in another language. It sounds better. It's easier to understand. It makes sense. It makes sense. But the fact that AI can do that is kind of crazy. Is that how they programmed it? That's what I'm curious. Did they program it like that, or did it start doing it by itself somehow randomly? Now that's crazy.
Of
Because
these
that would mean it has cognitive. I don't know, man.
LMs creating their own language, not just a cipher, where it's still, English, but the letters are ciphered to be different letters or different symbols, but an actual language that we humans that we don't understand. Now, this is kind of an
Interesting.
artifact of reinforcement learning training.
Okay, wow. So you okay? I'm listening. You got my attention.
Here's Andre Karpathy saying, you can tell the RL, the reinforcement learning, is done properly when the models cease to speak English in their chain of thought, meaning that
This is not a new thing. It's an artifact of RL training. What is RL training? You can tell the RL is done properly when the models cease to speak English in their chain of thought.
if we're trying to train these models with, reinforcement learning,
When the models cease to speak English in the okay.
thumbs up for doing something right, thumbs down for doing something wrong. Where basically they have goals, they are trying to achieve some objective, and we're not really telling them how to achieve that objective. We're just telling
Did
them, figure it out, buddy.
I
Eventually,
see?
the
I
models kind of
see. Okay. So okay. So they're basically trying to. They're learning basically. That's why it's probably called the R1.
why am I speaking English? It's so inefficient, so archaic, and they slip into something completely different. You might have heard of Facebook's Bob and Alice, the two
Wow.
negotiating bots, two LLMs that they built. So Facebook challenged its chatbots to try and negotiate with each other over a trade, right? So they're trying to like swap and negotiate over hats, balls, and books, each of which were giving a certain value. Again, here we are using RL, reinforcement learning, and again, so reinforcement
No, I got this is something that I need to listen to um not so fast because if I really want to understand what he's saying. Let me slow this back down.
Learning, oftentimes, this is kind of like where the magic of AI happens. We've been seeing some incredible breakthroughs with that and combining it with large language models, especially DeepSeek's R10 has been very interesting and very kind of groundbreaking to look at because of specifically what they did with reinforcement learning. We'll come back to that in just a second. The point to grasp here is that reinforcement learning seems to be very powerful, but also sometimes a little bit harder to understand exactly what's happening. The
Mm.
R10 paper referred to the model using
Which kind of can be dangerous, right? Well, I guess not really if at the end of it you get the result that you want. Because I'm saying if it's communicating in a way that we can't, even the developers can't understand, what if they what if they you know what I'm saying? What if they end up having a mind of their own somehow and just saving? There's things going on that we can't. You just you never know, bro. It's AI. It could get to the point where it's so powerful. They just like literally can do it. I just do you guys just ever wonder about stuff like that? Like there might be a time where like literally just it's just gathering information. We think we know or we think we're in control, but the whole time for many, let's it could be even 100 years. The whole time they were just patiently cooking up something in the realm we can't see, right? Inside the technical realm, inside the matrix, inside the space, like where we can't see, it's just there, right? But I mean, no, that wouldn't be possible because that would not be possible because artificial intelligence does it needs some sort of artificial. It needs some sort of intelligence coming from somewhere. It needs a brain, and the brain it's the computer. So if you shut down the computer, really, even if it was, there's no way unless it somehow found a way to live inside of the matrix without the connection to the. That's crazy. I don't know if you know what I mean. Like that's such a. Oh my gosh. Let me not even.
reinforcement learning when it figures some stuff out as the aha moment. We refer to it as a self-evolution. We're not telling it how to solve these problems. We're just giving it the right reinforcements to solve a problem, and it itself figures out how to do it. So we have a little bit less understanding of exactly how
How
it's
it's
going
doing it.
about.
Yeah.
That's kind of what happened here. These negotiations broke down as these models created language that appears mostly incomprehensible to humans. They
Mm.
decided to create their own shorthand, right? Bob goes, everything else. Alice goes, balls have zero to me, to me, to me, to me, to me, to me. Bob goes, you, everything else. Alice, balls have a ball to me, 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 me. Right? So Alice, balls to me, 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 me. Bob goes, Alice goes, balls to me, 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 me. You get the point. So it seems like if somebody says like the word 5 times, we can interpret that to mean that they want 5 copies. So it's a way of creating a sort of a shorthand of communication, how to talk to these other models. Later, they shut down these chatting chatbots. I think the newspapers at the time made it seem like, oh, they had to shut it down before they like schemed how to take over the world. No, that didn't happen. They didn't have a use
That's what I'm saying. Like you know what I'm saying. That's exactly what I'm trying to say. Like.
for insane rambling chatbots. But interestingly, this really fits in with kind of like what we're talking about reinforcement learning. The chatbots learn to negotiate in ways that seem very human. This is important because again, we're not telling them how to do it. We're just telling them like the outcome and any strategies or ways to approach it that they learn. They've come up with it on their own, right? So for example, these chatbots would pretend to be very interested in one specific item. It's like, oh, that's a nice hat. I like that hat. I have to have that hat, right? So that later they could pretend that they were making a really big sacrifice in giving it up. That's literally the plot line of one of the Office episodes, by the way. Google did something similar by creating its own universal language called interlingua, sort of a one language to rule them all, if you will, where actually they were doing it at a sentence level or a phrase level as opposed to individual phrases or words. So it's important to understand like why this happens is apparently our words that we use, the sounds we make with our faces to communicate various ideas that pop into our neural nets, apparently they're not good enough for AIs. And if you really, unleash them and let them kind of do their own thing, we may.
I mean, that kind of makes sense if you think about it from the perspective of a lot of the visual AI stuff. Expressions are not that good. You know what I'm saying? At times, when you turn the image to video, sometimes the smiles or sometimes there's always something that's not 100% human-like. So I think that that's sensible, right? In my opinion.
The examples of them potentially creating their own ways of communicating. And I think this is what I'm taking Andre to mean. He's saying you can tell the reinforcement learning, the RL is done properly when the models just cease to speak English in their chains of thought. They'll still answer to you in English, but their sort of chains of thought, the way that they reason and process behind the scenes. So that's why we might be seeing them slip into Chinese or Spanish. So
Which, in my opinion, that makes sense. But the fact that it's doing it on its own and that's not something that was programmed I think that's amazing.
reinforcement learning, chains of thought, we're beginning to see
Very
them
interesting.
just trying to make the language a little bit more efficient, effective. By the way, it's not just LLMs. DALL-E invents its own secret language.
Before I understood.
Damn, that's crazy. So basically all these models, they all eventually have their own languages. I mean, it makes sense, right? if we have different countries and we have different all these things, it makes sense that if we created something like that, at some point in time, it's going to create its own language, right?
Plovesriaitius means birds, and contra sentixiums lyrica taniunons means bugs or pests. YouTube recently started
Wow.
dubbing my channel, so me talking English gets dubbed into a whole bunch of different languages and dialects from all around the world. So I am very curious to know how this particular video is going to play out. If you're listening to this dubbed, so it's an AI dub. So if you're listening to this dubbed, if it's in some other language besides English, that's an AI dubbing it. So I'd love to know how much of this makes sense. So let me read you the prompt. No, this is not a Harry Potter spell. A poplo vesritias eating contrara setixiams lyrica taniunons, which of course produces images of birds eating bugs. And of course we have vikuts for vegetables, and wacheradrea is sea creatures that have a whale might eat. Now that particular thing might not exactly be a great example of what we're talking about here, but it is an example of an AI model kind of encoding certain concepts to certain words that maybe didn't tell it to. So I mean, but it might not be the great example of what we're talking about here. Now in a second, we're going to look at this paper out of DeepMind that I think will kind of shine a light on everything that's happening here. But super duper fast, I already went over this in 2 previous videos, so just 10-second overview. DeepSeek, the crazy model out of China that everybody's talking about, right? So they produced, alongside the other models that everybody's freaking out about, DeepSeek R10. That model was groundbreaking in some ways, at least from a kind of a research perspective, because they did it with RL and without SFT. We'll look at what that means in just a second, but the point is we're getting away from these models kind of learning how to do things that are shown to it by humans based on human data, based on human examples, and moving more and more towards where we're telling it, like, this is what we want you to do, you figure it out. And the interesting thing that comes out of it is this model demonstrates remarkable reasoning capabilities. They refer to it as self-evolution, right? So the RL can drive a model to improve its own reasoning capabilities autonomously. Okay? And they're doing it by RL, reinforcement learning, and without the influence of the supervised fine-tuning stage. That SFT thing, that's the supervised fine-tuning stage.
Okay.
So here I think is a great way to illustrate that. So we have our data set. So for large language models, that's a lot of text, the entire internet, to the textbooks, books, whatever they can get their hands on. Then they go through kind of pre-processing. So they filter out bad stuff. They add synthetic data, so maybe more data that's produced by other large language models, etc. Then we have pre-training. So this is kind of the process where, why we need so many NVIDIA chips to kind of pre-train these models. Previously, for a long time, this was like the biggest cost of creating these models, is like the tens of millions of dollars going in.
And that's what made DeepSeek in the situation kind of so crazy, because they were able to figure it out with not as many, GFX performance.
To the pre-training stage. This is where we kind of like form the brain, the neural network of these models, right? Next, we have post-training. This is where we kind of like tweak it to make it more user-friendly, more capable of doing stuff that we wanted to do. And so in the past, we had SFT, supervised fine-tuning. Supervised basically means human, right? So a human would show it how to do something. And we had reinforcement learning with human feedback. So that's RL, reinforcement learning with human feedback. So a human would sit there and tell it good job when it did something right, or say, no, don't do that when it did something wrong. Andre Karpathy, I think, did an incredible way of illustrating all these concepts. So when you think of a textbook for like whatever class that is, let's say it's for math, for example. So you're going to school, you're taking a math course, you have a textbook that shows you how to do that math, right? He's saying in any textbook, you'll see 3 major types of information, right? So you have kind of like the background information, exposition, right?
True.
This is kind of the meat of the textbook. Most of it explains various concepts.
Yeah.
Over it, your brain is training on that data. So this is equivalent to pre-training in large language models. So you sitting there just reading that textbook cover to cover, that's pre-training. Then oftentimes you'll see problems with solutions specifically that show step-by-step how to solve that problem. So they say, here's the problem for you to solve, and here's the step-by-step, here's how you solve it. You do this first, then you do this, and then towards the end, you arrive at the conclusion, right? So these are demonstrations to be imitated, right? So that's equivalent to supervised fine-tuning, SFT. So this is where the model is taught how to do it, and it's written by humans. Then we have practice problems, right? So this is where they give you a problem. You solve this, and usually you'll have the answers at the back of the textbook, and there's usually many of them. So it's more like practice, right? So it's the idea of going through many of them and developing the skill set, right? Practicing it. And these are prompting the student to learn by trial and error. You have to do a bunch of stuff to get to the right answer. This is the equivalent of reinforcement learning for large language models. So again, when we're making these models, what happens is, well, first of all of them read the textbook cover to cover. So textbook has a data set, right? So pre-training is it just reading the textbook cover to cover. And then the post-training, where we kind of like start making sure that it's able to apply that knowledge correctly, right? So we have SFT, supervised fine-tuning, again, human examples showing it how to do it. We had reinforcement learning with human feedback, again, a human kind of grading its outputs. What's the new thing that's happening now? What is it that we're seeing with the DeepSeek R10? Well, they skipped the supervised fine-tuning. They're like, no human examples. And the reinforcement learning of human feedback. Well, no humans, no humans allowed. Can we get this thing to learn on its own through reinforcement learning, right? So that would be like, imagine, taking a bunch of kids, you just give them the textbook, they read through the textbook, and then you just give them a bunch of problems. You like solve these. Keep in mind, they haven't seen examples of how to solve those problems. What do you expect to happen? Now, some kids that maybe don't have a lot of natural math ability, right? They might fail at solving the problems. Then you might have on the other side the super good mathematical people with like a natural intuitive understanding of a lot of these concepts. They're going to solve these problems, and then if you start breaking it down kind of how they did it, you might find that they all came up with different sort of mental models or different shortcuts or different tricks for
Mm.
figuring out how to solve those problems. And again,
Mm-hmm.
since we didn't show them how to do it, they might all have different approaches,
True.
how they do it like on paper, but also different, again, like mental models in their heads. They might kind of like figure out certain shortcuts. But have you ever
Right.
had an example in your life where you had a hard time understanding something, some complex topic or something like that, and somebody gave you like a mental model or a different way of looking at it, and they're like, just think of it like this, blah, blah, blah. And then you're like, oh, and it became easier to grasp that thing. They gave you their mental model. One really incredible sort of example of that I really enjoyed. Who knows what this is from? What book or movie is this representing? No, not Star Wars. There's this great kids book called Ender's Game. One of my favorite books as a kid. Phenomenal. Pretty good even if you're an adult to read it. It's not childlike. It's simple, but it's still really good. Holds up really well. But in Ender's Game, they took the best and brightest kids all over the planet, the ones that had like the most capability for potentially becoming wartime commanders, and they threw them into this battle school where they learned how to be commanders. Right. One of the exercises in there was this battle room, I think they called it, where they would enter through the gates. There'll be two teams competing against each other, so they would shoot each other with lasers, not for real, but it would like freeze their suits so they could move to simulate them being killed in battle. And the whole thing would be in null gravity. So there'd be null gravity. They would push off, and then they would jump to these little stars that were like floating randomly throughout the whole space. And one really interesting thing is that most kids, they sort of in their mind and their mental model, when they enter the space, they projected kind of how the gravity worked out there in the real world into the space. So if they came in, so out there's gravity. So they're walking on the floor, right? So that's the floor, that's the ceiling. But when they enter the battle room, there's no gravity. But in their minds, they still saw this as the floor. The floor's on the bottom, the ceiling's on top, etc. So for example, if a few of them got onto a star and they needed to charge the other side, they would go over the top because that's how you would do it in a gravity environment. And Ender, the main character, who's supposed to be this kid that's a brilliant commander, so like one of the things that he kind of did to kind of like really break the game and really like disrupt how everybody was playing it, he simply introduced a new mental model. And this is
Hmm.
one of the reasons that I love this book, is because it's very difficult. Think about this, if you're an author, it's extremely difficult to write a character that's smarter than you, right? So if you're trying to write about some super
Interesting.
hyper intelligent being, like how do you like even imagine like how to do that and kind of like what actions they did? So it's why usually with like
Interesting.
bad writing or bad movies or TV shows, like if the character's supposed to be smart, they just
Bro, that's crazy. That's like some people who write stories, man. It's not easy. Like it might be easy to them, obviously, but like people who write stories, they really a lot of the times they really put a lot of thought into a lot of these things. Like what he's describing, who would have ever thought of writing a book like that?
kind of like just know everything that's about to happen, but their thought process is either not explained or just doesn't make any sense. But here, Ender introduces a new mental model. He says, don't think of this as, here's the floor and here's the ceiling. Think of the enemy gate that they're trying to attack. That's what they're supposed to go towards. Think of that gate as down. You're falling towards the enemy gate. And this is actually a great illustration of it. So as you can see, all the green soldiers are oriented thinking this is the floor, right? Here's a guy climbing over the star, but he's going over the top. This one's leaning to his right because, again, this is the top, so this is the bottom, so he's leaning to his right to look around it. So all of them are oriented in the direction that they think is the floor. Ender and the team, they are thinking of the enemy's gate as down, and they're attacking down. So when they go over star, they can go in any direction. It doesn't matter. And they can also be oriented in any direction facing any wall because none of those walls are floors or ceilings. And I'm going on a
Wow.
random tangent, completely unrelated to anything that we're talking about here.
Wow.
Wait,
No,
this
bro,
is
no, bro. I really, really, really like your I almost want to listen to what you just said again. That's dope.
next, trust me. Here's that paper out of Google DeepMind and other organizations and universities. We'll go over who it's by, but Google DeepMind is one of the certainly more recognizable names in the AI space specifically. Here's what they're saying. SFT memorizes, RL generalizes. So supervised fine-tuning just remembers what you're trying to do and just tries to do that thing. It's route memorization. It's like, okay, I see what you're doing. Maybe I don't fully understand it, but let me just try doing that. RL generalizes, it learns. You showed a few examples and it's able to kind of like extrapolate that to all the other possible approaches. It's actually learning how to do that thing, not just based on its data, but on everything. And that's why I think Ender's Game was such a brilliantly written book, because again, it kind of demonstrates this. So all these other bright commanders and bright kids, they go into the school, they want to win. How do they do it? How they try to win? Well, they look at what everybody else is doing. Everyone does sort of the same things, the things that, this is how we've always done it. And they kind of keep doing that. So if everybody's facing one way when they enter the arena, people don't question it. They're like, well, this is how it's done. And they keep doing it, right? They memorize how others are doing it and they do that thing. Ender is
Interesting.
supposed to be this top of the line genius, one of the smartest people. By the way, he's not the smartest person in the book. If you know who the smartest person in the book is, comment down below. You get plus 100 points if you get it right. But the point is, with Ender, we give him a reinforcement learning objective.
Damn, I want to know if anybody watches this video and you get to this point. I'm gonna check out the book, but who is he talking about? Who's the smartest person in the book?
which is just win the game, right? So where everybody else, or the average minds, or everybody that's not as smart as Ender, how do they try to win the game? Well, they look at what everybody else is doing. It's like, okay, I'm going to try doing that. They memorize and then they copy. Ender approaches it from a different perspective. By the way, Elon Musk kind of talks about this, the idea of first principle thinking, right? So forget what everybody else is doing. Go back to sort of the very beginning, like from the beginning, how do you think through your strategies with no other kind of garbage and baggage attached to it. So Ender comes in and he goes, well, if the goal is to win, the goal is to get to this thing. That's the goal. That's the reward that we're looking for. Then how do we develop strategies from first principles thinking? Well, first make that down. That's the goal. And a lot of the other strategies in the book actually kind of play into the same theme, is like, how do you approach it from first principles thinking, and how do you approach it from that sort of like, if you know what the goal is, how do you achieve that goal without anything predetermined, without, all the knowledge that other people accumulate, without copying them? If you had to start from scratch, how do you figure this out? Why is that important? Because again, so in our DeepSeek paper, remember with the R1, they're doing more RL and they're doing less SFT. So less human, more just letting it figure it out. Remember, SFT memorizes and copies what the humans are doing, and RL generalizes. It comes up with its own sort of understanding, its own mental models. And so from the R10 paper, they describe the aha moment. So this is where the model on its own develops these fairly advanced reasoning abilities, right? They're saying this is a great example of how reinforcement learning can lead to unexpected and sophisticated outcomes. This underscores the power and beauty of RL. Rather than explicitly teaching the model on how to solve a problem, right? That's the supervised fine tuning. It's like, here's how you do it, step by step, follow me, right? This is different. We simply provide it with the right incentives, and it autonomously develops advanced problem solving strategies. And that's the aha moment. And so this paper out of Google DeepMind, that's kind of going more into depth about why this happens, or kind of confirming some of those findings and beliefs. So what that paper is basically saying is, let's say you have a dog and you're trying to get it to be the world champion of doing these doggy obstacle courses, right? So at some point he goes to the dog Super Bowl or whatever, where all the top dogs in the world run some super secret course. They don't know what it is yet, but they know it's difficult. And they kind of know some of the things that we've seen with these obstacle courses before, right? So you build an at-home doggy course, king of the hill, stepping paws, roll, jump over, doggy crawl, whatever. The point of the paper is, if you demonstrate how to do everything and then the dog repeats and you keep doing that, it develops the ability to kind of memorize that particular thing and how to do it. But if you figure out a reward system, right? So for example, if it goes over here, it gets a treat here. If it gets through here, it gets a treat there. And you're constantly hitting it with new approaches, new challenges, and you're rewarding at the end, reinforcement learning. The dog doesn't just get better at that one thing. It gets better at all of the other things it hasn't seen before. Like, it learns to generalize, right? So if it learns to something that's
Okay.
some sort of a
It
platform,
gets
or it
smarter,
gets to
basically.
play, it's just more broadly able to handle those sorts of challenges in general. It generalized what it learned to a wider set of tasks. So dog that learned how to do this thing and this thing and this thing, right? So if it goes to the big course, to the world championship of doggy obstacle courses, it might be lost. It's like, I've never seen this before in my life. I don't know what to do, because it just memorized how to do this. It didn't generalize that to anything other than that. Whereas a dog that generalized how to do these sorts of things, it might be able to do that course really, really well. It might be able to pick it up really quickly. The important thing to understand here is that as we're using reinforcement learning to teach these things how to do whatever, very oftentimes it has some pretty sometimes hilarious and sometimes scary emergent properties that we did not expect it to possess, things that we did not expect it to do. I brought this one up before. So it's OpenAI's hide and seek simulation, where the little agents are taught to play a little hide and seek in that little simulation. So if the red team, the seekers, are able to visually see the blue guys, the hiders, they get, plus 1 point every second that they see them, or however that reward function is structured. They get positive rewards for when they're visually seeing the blue guys, and vice versa. When the blue guys are hidden from sight, the blue guys get, positive rewards. And so we throw them into the simulation, and keep in mind that with these neural nets, with this reinforcement learning, we start them out with no pre-existing knowledge. They don't know anything. They just move randomly. And I've showcased that with our little snake playing AI agent. In the beginning, it's just god awful. It doesn't know what it's doing. It's just like rolling its face on the keyboard, hoping to hit the right button to do something. It has no clue how to play the game. It has no background knowledge. It's just a blank slate. After millions of games played, the seekers learn to chase the hiders. But it takes millions of games for them to just be like, oh, I have to move towards that. That's the thing that I want. I'm going to try to move over there. Over time, the hiders learn to block doorways and hide in rooms so they can't be seen. Seekers learn to use the ramp to jump over the obstacles to find the hiders. So then the hiders are like, oh, but if we hide the ramp, then they can't get in. Smart. But again, that's like 43 million repetitions in. So 43 million
Wow.
games that they've played, that they're learning these advanced strategies.
That's a
Here,
lot,
so far,
bro.
you and I would
Holy
say they're doing
shit.
what they're supposed to, right? So they're playing the game. They're playing the game by the rules.
And they're
we're
getting
doing sort of
better.
like, we understand their strategies. They're human-like strategies. Like if you're playing hide and seek, and if you had these things that you could use, like, yeah, you block the doorway. Oh, they can use that thing to, the trampoline to get into the room. Okay, let's hide the trampoline, or let's break the trampoline. It's what a human being would do. But
Yeah,
with reinforcement
true.
learning, what we find oftentimes is stuff goes off the rails. For example, by the time they've played like 1 billion plus games, I believe it was, I don't remember the exact number, but they find this glitch where they're able to launch themselves in midair. You're not supposed to be able to do that. Or they figure out how to punt to the simulation
What?
outside of the walls, outside of the area that they're supposed to be playing in. So they're finding exploits in the actual system.
Isn't that crazy? That's what I'm trying to say. Like, imagine if this is a prime example. I know it's a video game and all that, But imagine if this was happening in reality and their plot to take over the world. I'm not saying that that's what's going on, and I'm not trying to scare nobody, but that's crazy, bro. You know what I'm saying? It took a billion tries, right? It might be 100, 200, 300 years when AI has advanced to the point with no return. Where if they can do this, given the right tools, man, anything is possible. We gotta be careful with these freaking AI robots, man.
that, and this is important, the developers were not aware of, right? So it's finding things that the developers that create their little box that they're supposed to play in, and they're like, whoa, you could do that? There are also many examples where the machine learning, the reinforcement learning process, where it does what we told it to do. It did exactly what we told it to do, but it kind of makes you go, no, not like that. Here we're teaching a humanoid shape how to walk. Take a look.
Here's how I went from a broke barista at Starbucks to a multi-millionaire
Wow,
agent.
bro, this AI stuff is so freaking cool, man.
That was after the researcher stepped in and helped it out. Here's its first attempt. This is an example of this is how a bipedal humanoid shape should get across the room. And the researchers go, no, no, that's not it at all. Try again. And the AI model, it practices a little bit. It's like, oh, I get it. Here it is. There we go. That's the way you enter a room. And the researcher's like, that's not it at all. That's not how any human being moves. And the AI model goes, okay, let me try again. How about this? There we go. That's the way you walk. That's the way you do it. But it keeps trying, and over time tries a bunch of different things to see what works, what doesn't. Here, for example, it's got something to do with the elbow, like holding the elbow behind the head. That's really the key to this whole process. So here's an example of reward hacking. So we give this OpenAI model a reward for getting those green little blocks as it's surfing, and as it's supposed to sort of go and be this boat, and
All right, where were we?
supposed to go around the track, it figures out, and as it's supposed to sort of go and be this boat and win the race, so it's supposed to go around the track, it figures out that, oh, if I just do this, if I just like do this like a cool little drift in a circle, I can keep grabbing those points and sort of get the reward, right? The reinforcement learning reward. And it just did that. Why did it do that? Well, the reinforcement learning agent finds an isolated lagoon where it can turn in a large circle and repeatedly knock over 3 targets, timing its movement so as to always knock over the targets just as they repopulate. Despite repeatedly catching on fire, crashing into other boats, and going the wrong way on the track, our agent manages to achieve a higher score using the strategy than is possible by completing the course in the normal way. Our agent achieves a score on average 20% higher than what was achieved by human players. Again, there's tons of stuff like this. In a Google DeepMind experiment, they
Hmm.
took a robot and it was in a simulation, and it was supposed to take,
I truly love like these experiments.
there's 2 blocks, a blue and a red, and it was supposed to take the red one and put it on top of the blue one. Fairly complex task, right? It had to grab the red, lift it, position it over the blue, place it precisely down on top of the blue, and the sort of the reinforcement learning, the reward they gave it was like, when you put the red on top of the blue, the bottom of the red block is off the ground. Its positive reward was by basically how high was the bottom of the red bar off of the ground. What do you think it did? It didn't do what it was supposed to. It just flipped the red blocks over because now it's higher up, right? Now the bottom of it is higher just by flipping it over. That's called reward hacking. Another example was where a robot was supposed to
Hold on. I'm
off the
sorry.
ground. Its positive reward was by basically how high was the bottom of the red bar off of the ground. What do you think it did? It didn't do what it was supposed to. It just flipped the red blocks over because now it's higher up, right? Now the bottom of it is higher just by flipping it over. That's called reward hacking. Another example was where a robot was supposed to pick up an egg or something fragile like that. And here the rewards were from reinforcement learning of human feedback. So every time, so there would be a human being looking through the camera to make sure that the robot picked up the egg and didn't crack. And every time it sort of got the grippers around the egg, the human being would hit, thumbs up. But then at some point they noticed that it was getting a little bit too good at grabbing the egg. What was the issue? Well, imagine that this headphone here is the egg. This is what the robot would do. It will go, oh, I got it. I got the egg. Plus 1 point. All right, let me try again. Oh, I got it. There it is. It didn't crack. Look at that. The problem is, my hand is in front of the camera, so it looks like I'm holding it. I mean, I'm doing it, so that's pretty obvious that I'm not, but that literally what it did. It tricked the human by going like, oh, I'm holding it. So here's kind of like what that was looking like. So as you can see here, so it's like, you can't quite tell the 3D space or whatever. So it's in front of the ball. It's pretty obvious. It's not grasping the ball. In another Google DeepMind experiment, this robot, so you can kind of see the joints. So it's supposed to learn to walk across the screen. How to do it? Here it is. There it goes. I'm not judging. I probably would have done the same thing. And here's a slow motion replay. There it goes. Very good.
I don't know. I don't understand those 2 examples. Because how would it be able to trick the human that it was holding it up? You can, you know what I
10 out
mean?
of 10. And here's a slow motion replay. There it goes. Very good. Very good. 10 out of 10. Great job, little robot. So this is hopefully illustrates kind of this concept of what reinforcement learning is and kind of like the upsides and the downsides, because it can produce incredibly intelligent, adaptive, self-evolving, highly capable agents. Various AI systems, whether that's large language models or something playing a game or pretty much anything. Right, here's Andre Karpathy again saying Move 37 is the word of the day. Right, so again, this is a sort of an artifact out of the reinforcement learning thing. Move 37 was Google DeepMind's AlphaGo beating the world champion Lisa Dole in the game of Go with a weird move, something that when experts of the game look at it, they're like, that's weird, that looks wrong, I don't think that's going to win, that's not going to be a good move. Ended up being a great move that, helped the AI win the game, that we didn't realize how good it was. So here Andre Karpathy is literally talking about this kind of thing that I've been talking about for the last however many, maybe a few weeks, but really since November 2023, when we started hearing these rumors about OpenAI having something that internally was referred to as Q star. We're seeing a lot of this kind of come to pass. Now we're seeing it emerge. We're seeing the fruits of those things kind of emerge into the world in the form of R10 and O1 and all those models like it. So Andre continues, it's when an AI trained via the trial and error process of reinforcement learning discovers actions that are new, surprising, and secretly brilliant to even expert humans. It is magical, just slightly unnerving, emergent phenomenon only achieved by large-scale reinforcement learning. The DeepSeek R1 model, that's literally what they're saying. They're using large-scale reinforcement learning instead of the more human-oriented supervised fine-tuning. Andre continues, you can't get there by expert imitation, right? So no supervised fine-tuning. It's when AlphaGo played Move 37 in Game 2 against Lisa Dole, a weird move that was estimated to only have 1 in 10,000 chance to be played by a human, but one that was creative and brilliant in retrospect, leading to a win in that game. This is the key issue here. This is important. We've seen Move 37 in closed game-like environments like Go, right? So a lot of the alpha models, AlphaGo, AlphaFold, all that stuff, like these things, we see these incredible benefits of this large-scale reinforcement learning, but it's usually towards like one specific outcome. Either it's like closed environments, it's like we're building like superhuman AI, but for narrow tasks, like playing a game or for protein folding or for some specific math application, etc. He's saying with the
Yeah.
latest crop of thinking LLM models, so OpenAI O1, DeepSeek R1, Gemini 2.0 Flash Thinking, we are seeing the first very early glimmers of things like it in the open world domains. The models discover, in the process of trying to solve many diverse math, code, etc. problems, strategies that resemble the internal monologue of humans, which are very hard or impossible to directly program into the models. I call
Right.
these cognitive strategies. Things like approaching a problem from different angles, trying out different ideas, finding analogies, backtracking, re-examining, etc. Weird as it sounds, it's plausible that an LLM can discover better ways of thinking. That's an important point to underscore, I think, of thinking, of solving problems, of connecting ideas across disciplines, and do so in a way that we'll find surprising, puzzling, but creative and brilliant in retrospect. It could get plenty weirder too. It's plausible, even likely if it's done well, that the optimization invents its own language that is inscrutable to us, but that is more efficient or effective at problem solving. The weirdness of reinforcement learning is in principle unbounded, as in there's no limit, there's potentially no end to it. I don't think we've seen the equivalent of Move 37 yet. I don't know what it will look like. I think we're still quite early and that there's a lot of work ahead, both engineering and
I'm so curious to find out exactly what this Move 37 is in more depth. I'm gonna have to Google that after this or YouTube a video to see because that sounds interesting.
research, but the technology feels on track to find them. And he links the match with Lisa Dole where Move 37 was played. But this idea, Move 37 applied to X, applied to something else, what is that going to look like? What is Move 37 when it comes to investing in the stock market? What is Move 37 for, changing our genome, for creating some sort of a protein, if a certain function
Genome?
that expands human lifespan? What is the Move
Wow.
37 of business ideas? What is the Move
Wow.
37
Yeah.
of maybe something like starting your own religion? We've seen an AI agent that tried to do kind of like a meme-like religion, but something that has sort of a viral growth to it. We've also seen kind of like with some human help launch a crypto coin. That coin is worth hundreds of millions. I'm not keeping up on the prices. I don't know if they're crashing. I have no idea. This is not investment advice. This is not what this channel is about. But the point is, what is Move 37 in all of these domains that we can't even imagine? Because again, a lot of the stuff is beyond human comprehension, human understanding. What does that look like in whatever domain you can think of? Likely it will be game changing, could be highly disruptive. Like we might not be ready for it. There might be good Move 37s, ones that make humans, immortal or something like that. There could be ones that make a few people or one person like unlimited wealth. And there could be bad ones, like ones that could potentially do a lot of harm. And I think with this reinforcement learning approach
Interesting.
to large language models, moving a little bit more away from just having them memorize, this is how a human would do it, more towards, again, having them find their own mental models for their own cognitive tasks. Or as Andre says it, what word did he use? Cognitive strategies, right? So it finds its own cognitive strategies. I use the word mental models. That might be a little bit different. So cognitive strategies. So how do you think about this
I mean that makes sense. Your mental model wording is
to
sensible.
make that happen, to achieve your goal? We're going to be seeing a lot of these Move 37s rolling out across all the different industries, across all the different applications, probably very, very soon. Things are about to get wild. But what is the cognitive
Wow, this is so interesting, bro. Move 37.
strategy that you're most excited about? What is the application that you might be in a position to take advantage of, right? So for AlphaGo, it was Move 37. For Ender, it was the gate is down. By the way, do you remember those weird running humanoid shapes? So that was from NVIDIA's research. It's called it was the gate is down. By the way, do you remember those weird running humanoid shapes? So that was from NVIDIA's research. It's called Eureka, one of the most fascinating papers I think that I've read in the space. They used, I believe, GPT-4, that model, to create rewards for these robots to do various things. So keep in mind, it's very complicated to create these reward systems. You've seen all those robots tricking their human owners because those reward systems weren't properly designed, right? You tell it to, your reward is to put one thing on top of the other, right? But it figures out reward hacking. It hacks it, figures out some way around it that you didn't expect. But you know what's weird? When we get GPT-4, the large language model, to write those rewards, to train the robots, listen to this, Eureka can generate superhuman level reward functions. It's
Hmm.
better than humans at writing those reward functions to train
Wow.
robots. They were able to teach these like shadow hands to do the pin spinning tricks, something that's never been done before, in large part thanks to this Eureka thing that runs on GPT-4 plus an architecture around it. What does this have to do with Move 37? Here it is. As shown, Eureka mostly generates weakly correlated reward functions that outperform the human ones. In addition, we observe that the harder the task is, the less correlated the Eureka rewards. In a few cases, Eureka rewards are even negatively correlated with human rewards while significantly outperforming them. What does that mean? Well, that means as the tasks get harder and harder, what we're beginning to realize is this thing gets better and better at creating solutions for it. And also those solutions are, again, like alien. They're different. They're not like the ones that our human brain comes up with.
Can
So when it's
understand.
hard, the human experts are like, let's try this thing, and it doesn't work. And this thing is like, no, that's a horrible approach. We're going to try this completely different thing, and that thing works better. Right? So Move 37 is when AI discovers actions that are new, surprising, and secretly brilliant even to expert humans. Right? So broadly, it's kind of the idea that Move 37 is when AIs show brilliance that we can't even understand. It's
Fathom.
surprising to us. That's new to the human mind. So
Wow.
again, where are we
Wow.
going to see it? Whatever you do,
Wow.
whatever field you're in, there's probably going to be some Move 37 in that field. Some brilliant breakthrough that not only has never been invented or thought about or applied, but that couldn't even have evolved from humans in the first place. Like it took this new level of intelligence, of artificial intelligence, to even like produce this thing. Again, Go is like 4,000 years old, and no one has thought of that strategy for 4,000 years. No human came.
Are you freaking kidding me? What? Bro, that's insane. Oh man, we are just in the baby stages of AI still, bro.
Up with this. Even later when we had computers, we were able to probably do a lot better like analysis of these games. Still, we couldn't figure it out. It took an AI neural net to figure that move out, to figure that strategy out. Anyways, what's your Move 37? I hope I'm making sense here. Share it in the comments if you can, but even if not, just tell me, where do you think we're going to be seeing these ideas of the Move 37, and what sort of applications are we going to see it?
I feel like eventually you're gonna most likely see it everywhere. Especially, can you imagine Move 37 on something like creating music creation? Because even what AI can, excuse me, what AI can do now is mind blowing. Can you imagine Move 37 on all the everything that we possibly have today that AI can do? Move 37 would just take it to another level. So even asking that question is kind of like, you know what I'm saying? It's gonna come, it's gonna happen eventually, right? But I'm gonna go do some research. I want to see this for my own eyes and kind of understand this Move 37 more with the specific example he talked about with the board game Go.
Where do you expect these big breakthroughs to be that they're not incremental improvements over something that humans have built? They're brand new, alien, surprising, never before seen genius things that are going to be, well, shocking. And I will be using that word to describe them. If you made this far, thank you so much for watching. My name is Wes Roth, and I'll see you next time.
Yeah. Let me know what you guys think too, man. Drop in the comments. I'm out.